numbers because that just shows that it's the first occurrence, right? 15 is the first occurrence. Where is the next occurrence going to be? Madeline, what do you think? How do you know that? When I don't even see it on my stream, but do I know that it's coming down the road? I know that it's coming down the road because 30 is a multiple of 3. And now I can see a pattern starting to develop. Do you think I'm going to be circling all of these numbers?
Yeah.
Yes, all of these numbers are going to be common multiples between 3 and 15. And if you really want to investigate why, you have to look at their prime factors. What are the prime factors of 15? What are the prime factors of 15? 3 and 5. So because 3 is a prime factor of 15, then every single multiple of 15 and 5 will be a multiple of 5 and 3 separately. So it's kind of connected to that GCF business that we were doing earlier last week. There's one that has 3 terms on it, 2, 3, and 5. Do you see that one? Is it number 16?
Yes.
Okay, let's look at that one. 2, 3, 5. So I'm looking for the spot where 2, 3, and 5 all intersect their multiple streams. Are you able to start maybe thinking about where it's going without writing it down? You might be ready to do that. But just for the sake of demonstration, here, let me write it down. 2, 4, 6, 8, 10, 12. And your brain might be going, wait a minute, 3 is on the 12, 6 is on the 12, but neither of those are synced up with 5, so I have to keep going. After 12, 14, 16, 18, wait a minute, 18's on the 3s. Oh, but it's not on the 5s. I have to keep going, right? So my brain's going to keep going. Let me use a different factor to see if I can make a good guess about where the stream is headed, right? So 5s are bigger chunks of numbers. So maybe I use those. Are we seeing anything where they're going to intersect yet? What?
30.
So I'm hearing 30. I know down the road on the 3 stream is 30, and I know down the road on the 2 stream is 30. So I'm comfortable saying that is the first occurrence of the shared multiples. If that's the first occurrence at 30, where will the second occurrence have to be, everybody?
16.
And then what?
9.
And then what? They have to be evenly, they will infinitely be 30 away from each other. It's cyclical, it's called. It never ever stops. It just keeps repeating their pattern over and over infinitely, okay? Let's see. I'm going to stop the share for a second. Did you guys know Raina is in Lebanon on the other side of the earth, and she is here on the Zoom with us? Isn't that so cool? Mm-hmm. She's in the other class. Raina, are you still in Lebanon?
Yeah,
What time is it there?
6:02 p.m.
I know, look at it, it's dark outside, do you see? It's dark outside where she is. It's so cool that she's on the other side of the world and still joining us at class.
Wait, where is she again?
You're in Lebanon, right, Raina?
Yeah.
So apparently some people here don't know where that is, so I'll have to show them on a map later, okay? All right, we're gonna move to page 80 now, everybody, okay? Page 80. And what we're gonna do on page 80 is I'm going to demonstrate a couple from each section and then let you work. Here in my mask.
Yeah.
This is what happens when you have long hair, it's everywhere. Sometimes it gets caught like under my arms, or it gets caught in my ring or in my pen. Workbook page 80. the first set of instructions for numbers 1 through 8, I believe.
On page 80.
Yes, on page 80. Here we go.
East Common, and West Common.
So the first 9 are exactly the same as yesterday's assignment, but instead of finding the first 4 common, you're only finding the first common. Okay? But specifically, it has to be the first time they meet. So the least common multiple, the smallest shared multiple. So I knew for that last one that they would share 30, 60, 90, 120, 150. I know they have infinite shared multiples, but I only want the first one.
Or I'll see.
Yep. So 1 through 9, let's go and find the lowest single shared number they have, okay? So think about 4s and 10s. Do we really have to write out all the 4s and all the 10s? No. Why don't we just start saying them, and as soon as you get to a multiple of 4 and 10, you stop, okay? Remember what we did yesterday for the 4s? What did we do yesterday? This? 4, 8, 12. Remember we did that?
Yeah, this is 6 quiet.
But what did we do for 4s? We said 4, 8, 12, 16, 20, and I saw someone go like this, stop, because 20 is both a multiple of 4 and a multiple of 10, right? So you should say that's the answer. That's the lowest common multiple they share. Excuse me for a moment while I already had it. I can't give it to you.
I had it like 2 months ago.
Yes, me too. So
We have antibodies.
I'm done.
Me too. Woo.
All right,
Antibodies.
how's that? Whew. That's much better. So how about the next one, number 2? Where do the 3s and the 5s meet? Let's start saying the 3s. And then when we get to something that we also know is a multiple of 5, we stop. Ready? 3, 6, 9, 12, 15. Stop! 15 is a multiple of 3 and 5. Okay.
Number 1. What was the name?
20. Number 3.
2 6s.
Between 6s and 8s. Now this one's a little trickier. You might want to look at your multiplication charts to guide yourself because 6s and 8s are pretty difficult to get accurate. Here we go. Let's say 6, 12, 18, 24. Stop. 24 is also a multiple of 8, right?
8 times 3 is 24 as well.
Mhm. All right. I'm going to let you go with the rest of those. But look at the ones that have 3. What does that mean? We have to find the spot where all 3 of them share a common multiple. So can we please do one of those together? I would like to do number 7, please. 2, 5, and 8. 2, 5, and 8. Now you can start saying them to yourself, like 2, 4, 6, 8, 10. But you're going to get to your answer quicker if you pick the biggest one to start with. Okay, let's do the 8s. Why are you going to get to your answer faster if you pick the bigger number?
Stop at 40.
Stop. How come using the biggest number is going to get you your answer faster? It takes longer to go 2, 4, 6, 8. It takes longer to work through the same number line as you would taking off bigger chunks, 8, 16, 24. So start with the bigger number to help you reach the common multiple faster. Good job. So 40 is the answer for number 7. All right. Yes.
Do we have to do 4 like on page 79, or do we just have to do one?
You just do one now. I'm training you to not have to write a list out anymore. You should be able to either do it mentally or just have to write down one of them to get you going with the patterning, okay?
Oh, I got one.
Stop talking. 10 through 17. Please don't think this is anything different. It's not. Just the location of the numbers that you are comparing has changed. We're prepping for what's coming next, and that's fraction operations, meaning I'm going to be teaching you how to add, subtract, multiply, and divide fractions. Something, though, that you need to understand next chapter is that you can't add or subtract fractions that don't have the same structure. And by structure, I mean the same denominator,
Which should be the bottom.
which is the bottom number. So next to number 10, can everyone write this little diagram? Numerator is on the top and the denominator is down. Denominator is where? Down on the bottom. Denominator is down on the bottom. We have to make sure that fractions have the same denominator if we want to combine them, okay? So if I'm looking at number 10, what are the two featured, oh, that's not it. What am I doing? I've written this number too many times. Is it 2/8 and 3/12? So if I wanted to combine those fractions, I can't until I convert them into a denominator that looks like each other. So looking at 8s and 12s, those are the denominators that we're working with right now. I have to find the first place that 8s and 12s meet. So should I say my 8s or should I say my 12s? What would get me there faster?
Wow.
Say my 12, 24, stop. That was easy, right? So 24 is the answer. 24 is not only the answer, but 24 is the denominator I'm going to need when I start to convert fractions. And that's coming next chapter. Okay? All we're doing is least common multiple, but we're locating it in the denominator section. So please look at number 11 and tell me which two numbers are you finding the least common multiple of? 3 and 5. Look at number 12. What are you finding the least common multiple of? 16.
4.
What about 13?
9, 4.
What about 15?
2, 4, 5.
2, 4, and 5. It has to be all three of them. Okay. I think you can handle now working through 1 through 18 independently. And then we're going to meet up in about 10 minutes to chat about the problem solving ones, but you're not going to do those independently, okay? So I'm going to pause my recording and let you have some work time. And we'll meet back to talk about the problem solving ones in a moment. We're going to talk through those problem solving ones a little bit now, okay? So the problem solving ones talk about, you have to read the first one. The other class was like, what? When they read the first one. You know our book tends to be a little wordy.
Like the last one. Brian and the quiche.
Yeah, brain and the quiche, yeah. Okay, number 19. Now let me just read it out loud. Let it wash over you. Are the common multiples of two numbers, okay? So what we've been doing all day, the common multiples of two numbers, are they always the multiples of the least common multiple? What? Multiples, 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 multiples.
No.
It's hard to understand what they're asking. But what they're trying to ask is, will the multiples be predictable as you go through the number line? They should have said that. Is there a way to predict the next multiple without having to write down the multiple stream?
Yes.
How? Yes, use your brain, but you establish when the first occurrence was, and then what? Just use that same pattern across the number line infinitely, right? So for number 19, please write this.
Okay.
Yes, because patterns exist infinitely. Infinitely is INFINITELY.
How do you spell exist?
EXIST. Yes, because patterns exist infinitely based on the first occurrence. Based on the first occurrence, and occurrence is OCC. URENCE. OCC. URENCE. So if we know the first time they intersect, the first time they meet, then we can forever develop a set of numbers where they will intersect, right? We're primarily going to be using the least common multiple, the first occurrence, because it's a smallest number, it's the easiest to manipulate, it's the easiest to work with. Number 20, what do you think about this one? Here's a fruit tart. They're really into breakfast foods lately. A fruit tart is already cut into 4 equal size slices, right? More slices are going to be cut so that all of the slices will be the same size.
They're already all though.
They already are all the same size, right? What number of slices are possible? Explain how you found your answer. So let's just talk about it instead of write about it. Let's talk about it. William, did you have a thought about this?
Yes.
What do you think?
You could have any multiple of 4, so you could do 8, 16, and it goes on.
Why are you saying I could only have any multiple of 4?
Because you can only,
Cut it based off of what I already have, right? I already have 4 slices, so I can't change that. I can't put it back together. So I have to base my new cuts on the original cut. How many to start? 4, right? So what's the next multiple after 4? 8. So I could have 8 slices. Then I could have 12 slices, or I could have 16 slices, or I could have 20 slices. And then after that, it would get pretty mushy, wouldn't it? Because those slices would be so tiny, it wouldn't be. But you could cut more, but it probably would be a pretty miserable looking wedge. It wouldn't look like much at all. But that's where we're gonna have to focus our answer is only multiples of 4 are possible because it's already cut into 4 pieces to start. So I have to base my equally sized pieces off of the first cut, which was 4. All right. And then we're not going to be doing the last one today. I've worked it into our discussion earlier. So that is your homework for today. It looks like you finished it up, right? All set? No. Have a great weekend, everybody. Next week,